All quadratics have two solutions, but some of them are imaginary. We can solve quadratics which have no real solutions if we introduce imaginary numbers. A quadratic has complex roots when the bit under the square root is negative. Imaginary numbers are the square root of negatives. We say that -1 is the imaginary number I. This means that I squared is -1. The difference between complex and imaginary numbers is that complex numbers have a real and an imaginary part, whereas imaginary numbers are just multiples of I. Let's have a look at example number 1. Part A. We need to simplify the square root of -36. This is the square root of -1 times the square root of 36. This simplifies down to 6 times I. For part B, we need to find the square root of -28. We can split this into the square root of -1 times the square root of 28. The square root of 28 can be broken down further into the square root of 4 times the square root of 7. This all simplifies down to 2 root 7i. When adding complex numbers, you add the real parts together and the imaginary parts together separately. We can also multiply complex numbers by a real number by doing that number times the real part and that number times the imaginary part. Let's have a look at some examples of that. Part A, we have to add the real and imaginary bits together, and this gives 9 plus 8i. Part B, we do the same thing, but be careful because we are subtracting. Part C, we are multiplying, so let's times each thing by 2. This gives 10 minus 16i. Part D, we divide each term, this gives 5 plus 3i. In this exam question, we are given two complex numbers and we need to find A and B. We can do this by subtracting and comparing. When we subtract, we get -3 minus A, plus B minus 9i. We compare this to the 7 plus 2i we were given, and we can see that the -3 minus A is equal to the 7 and the B minus 9 is equal to the 2. Which gives our two answers. Next, let's look at solving quadratics with these complex numbers. The first one is quite nice, just subtract 9 then square root. The square root of -9 is either plus or minus 3i. The second one, we complete the square as you would usually for this type of quadratic which you cannot factorize. Now we rearrange for x, making sure when you have negative square roots you write them in terms of I. Finally subtract over the 3 and we get z as either -3 plus 4i or -3 minus 4i. For this last question, it tells us there are distinct non-real roots, which means that the bit under the square root, also known as the discriminant, is less than 0. Let's sub in the values from the quadratic which we have here. This gives b squared minus 44 is less than 0. This means that b is between positive and negative 2 root 11.